Well, today's lesson is on the rock cycle. Rocks are a combination of minerals that are from the Earth's surface. For instance, limestone is made up of calcium carbonate, but most rock is made up of two or more types of minerals. For instance, granite is mica, feldspar, and quartz. Uh, so today what we're going to be taking a look at is really how rock changes over time. And the way it does that is this kind of a three-step process. And the rock cycle is going to help us understand that. So here is the rock cycle, and there are three parts: igneous, sedimentary, and metamorphic. And it's a very dynamic process, not a static one. So it doesn't necessarily always it doesn't always go like from igneous to sedimentary to metamorphic. Depending on the conditions above as well as below the crust will determine which way the rock is going to go. But for right now, let's start with the igneous and kind of go around the horn, if you will, and talk a little bit about what happens to rock as it's transformed. For instance, let's start with igneous rock. Igneous rock, things like granite, if it's exposed to the elements and it's above ground, it's going to begin weathering and eroding. And when it does that, little pieces of it will break off. Also, freezing and thawing is probably one of the most effective ways, especially in the Sierra Nevadas here in California. As it does that, it breaks apart the rock and it makes it into smaller and smaller pieces that we call sediments. And as those sediments are washed away by or blown away by either the water or the wind, they begin to compact. For instance, if let's say this is a mountain kind of ridge here, and then we get to this flat or valley portion of it, all of that sedimentation begins to start building up. And as it does that, it creates a lot of pressure and a lot of weight. And as it does that, it starts to compact those various layers. So that gets us to the next kind of rock, and that is called sedimentary rock. The sedimentary rock is all the sediments that came off the igneous rock, and as it's building up those layers, more and more weight's added to it, and more pressure. And as there's more pressure, there's also more heat. And when that heat gets to a certain point in time or a certain pressure, all the various chemicals within those layers begin to interact. And because of that heat and the pressure and the weight, the sedimentary rock begins to change itself into another kind of rock. For instance, in sedimentary rock, let's say limestone, for instance, if it undergoes a certain amount of pressure and a certain amount of heat, it'll turn itself basically into marble. And there's a lot of examples of that kind of thing happening. So when we get to this metamorphic rock, it means it's changed. Like, for instance, from limestone to marble. And as the metamorphic rock goes further and further down into the profile of the Earth's crust, its mantle, it will come into contact with magma. As it does, it melts. And when it melts, then it's pushed up. And as it cools, and if it cools underneath the Earth's surface, it's a different kind of igneous rock. If it cools above the Earth's surface, it will become another kind of igneous rock that we'll talk about. But like in many processes here on our planet, like for instance igneous rock, if it stays above the surface and then it gets pushed down beneath the surface and gets piled up, it undergoes heat and pressure. And then that'll convert that igneous rock directly into metamorphic rock and go through this process again. If this metamorphic rock is above the Earth's surface and undergoes erosion, it will produce sedimentation, and then it undergoes compaction and cementation, where all the chemicals begin to interact with each other and make more of a solid substance. That will then become sedimentary rock. So it isn't just happening a 1, 2, 3 process. There are other things that will impact it and affect it. So let's talk about metamorphic rock in a little bit more detail. First, it means change. It means transformed. In other words, this rock has been changed from one thing to something else. And it usually is done by heat or pressure. Like for instance in the sedimentary process, as that sedimentary rock undergoes the pressure and the change over time, it becomes metamorphic rock. Like I said, limestone to marble is one. It can be modified a little bit by, of course, magma, because it'll heat it up. And some samples of metamorphic rock are things like gneiss. And of course, if you look at gneiss, you can actually see the layers of sedimentation. So it came from a sedimentary rock. You can see those layers. And of course, in marble, you don't quite see the layers as well. But definitely in slate, you can see these layers that were laid down a little at a time. And it was pressed together to make more of a hard substance or rock. Some words that might help you remember are those kind of metamorphic rock. Things like heat, that created it, pressure created it, and of course the wind under a change because of that heat and that pressure. What gets us to igneous rock, as I've said before, and here's a piece of, this is from, I believe it's Yosemite, and you can see this is sticking right up. It's half dome right there as it sticks up. It's just this piece of granite that got thrusted up above the Earth's crust, and as it does, it's being exposed to snow and thaw. It's becoming exposed to the fog. It becomes exposed because of the sun, and it begins to erode. And as it erodes, it of course flows down, and there's sedimentation down here. But igneous rock, it basically is formed after it's been cooled. It's come in contact with magma. It starts to cool off. And of course, because it's heated up so high, it forms these crystals, what further changes the composition or physical characteristics. If it's formed underground, it's called intrusive igneous rock. And typically, like the Sierra Nevada, was formed in an intrusive way. So it cooled underneath, and then it got pushed up because of the plates. And those big granite peaks that are very typical of the Sierra Nevada were pushed up. And of course, now they're exposed to erosion. If it's formed above the ground, and it actually peaks its way through the ground, possibly the magma found a vent, they become lava, and it mixed with some other substances, that would be extrusive. And some examples of igneous rock, things like obsidian. And obsidian, of course, the Native Americans made arrowheads and other types of tools because of it. It's very glass-like because of the high temperatures and heat. And then here's another kind of scora. This is kind of like pumice, and as it kind of bubbles up and through, and then of course it breaks the Earth's surface, air is kind of injected into it. It's very lightweight, lots of pores in it. And then granite. And on granite, lots of other substances were mixed into it. It's a very hard, dense type of rock. And then the word bank that help us understand igneous, things like magma, which is the thing that kind of heated it up, makes it kind of glassy, hard. Lava, it usually mixes with the air, and as it mixes with the air, it makes it more light and has, of course, holes in it. It's more porous. And then lastly is a sedimentary rock. Sedimentary rock is formed primarily from particles of sediment that have eroded away, whether it be the thawing effect or water action. But it's transported by water action primarily. There is a little bit of wind involved, but primarily it's water that is deposited, and that's the thing that gets it those layers. You can see the layers be formed in it. So it's basically formed layer by layer. Like here's a layer right here that was formed. Then possibly the next season or the next time that there was a rain event, there's another layer, and then there's just another thicker layer right here, and on. And as it piles up, because of the pressure of it or the weight of it, it heats up and makes some of those chemicals react with each other to kind of cement it as well. And then, of course, it's turned into rock by this lithification. The lithification is that pressure, the heat. And as that heats up, as I said before, the minerals react because of their chemical makeup. And of course, in this particular case, it's also going to form the fossils, because as fossils are formed, the minerals from rock kind of replace the bone, and as it does that, it leaves an impression. And examples are limestone, conglomerate, and sandstone. The sandstone, as you can see here, it's mostly just, there's faint layers, but it's basically all those particles that were smashed together, and the pressure kind of cemented them together so they would make a rock. And you can see some of the limestone has quartz in it, and that's what part of course, the marble is when it undergoes change. And the conglomerate is usually the larger, bigger stones, and gets maybe tumbled around, primarily because not only water action, but also could be ice moving across, like glaciers. And the word bag for that would be things like erosion and weathering. So there you have it. That's the rock cycle. Like I said before, two things you need to kind of remember about it is it doesn't always follow the same cycle. It kind of depends on the physical attributes of the rock itself, but also about the conditions it faces. And the second thing is it's important to note that all of the rocks themselves are usually made out of two or more minerals. So I hope that's helped, and we'll be seeing you soon. Thanks.